Good morning, everybody. Welcome to lesson 8.1.3. Today, what we're going to be talking about is angles in regular polygons. And to start, what we have here is a warm-up problem that I would encourage you to get on your notebook paper. Draw the figure as is. And then what we're going to do is we are going to kind of recap some of the stuff that we did last week. So if it's helpful for you to pause the video, why don't you go ahead and do that? I'll give you some time to just copy down the figure. And what we're going to do is we're going to find the sum of the measures of the interior angles of the hexagon first, and then we're going to solve for x. So to begin, if you need to pause at any time, that's just fine. As a reminder, in this particular instance, we're dealing with a hexagon. And a hexagon, remember from our notes from last week, is 6 sides. And so one big one big theorem that we learned, or one big equation that we learned, is the following: the sum of the interior angles.
To whom should I send a message?
Nobody, Siri. The sum of the interior angles in any polygon is given by the following equation, and that's n minus 2 times 180 degrees. I'll kind of explain this a little bit, but n represents the number of sides in our shape. And so in our particular instance, that would be 6. And so this says, this formula, if you take 6 minus 2 times 180, that will tell you what all of the individual angles added up together equate to. So this, if you add all of these angles all the way around, n minus 2 times 180 will do that for us. So let's go ahead and determine what the measure of all of the interior angles in this hexagon will turn out to be. So the sum of the interior angles of the hexagon.
I found this on the web.
Sorry, Siri continues to want to talk to me. So the sum of the interior angles of the hexagon up above is going to be given by 6 minus 2 times 180 degrees. And when we type that into our calculator, we're going to find out that that's 720 degrees total. So all 6 of our angles here are going to add up to make 720 degrees. So that's the sum. So how does that help us now? Well, we're going to try and determine the value of x. So if I were to take and add up all of the angles here together, I know that they're going to equal 720. So what I need to do right now is I need to add them all up and then set them equal to 720 and solve. Let me show you. So hopefully you're able to see what I did now as I added up all 6 of those angles from up above, set it equal to 720, and now what we're going to do is just combine like terms. So I'm going to add all the x's and all the things that don't have x's together. And that's going to turn out to be 18 x's, and then 1, 7, 1, negative 5, negative 4. Those actually all cancel out. So I'm just left with 18x equals 720 now as I go and I try and solve for x. I'm going to divide both sides here by 18 in order to get x all alone. And when I do that, the 18s cancel each other out, and 720 divided by 18 is 40. So that tells me that x in this instance is equal to 40. So we're going to use this understanding, this big formula here quite a bit today and moving forward as well. So if you haven't got this on your notes, this would be something to start with, n minus 2 times 180. But what's going to happen here is we are going to detail a little bit of this lesson here. This lesson here is going to deal with lesson 8.1.3, which is talking about what if it's a regular polygon? What happens if we have a polygon that's regular? And I'll talk about what it means to be regular here in a minute. We talked about that quite a bit in a previous chapter. So I'm going to start my notes now. If you're going to write a title down for today in your notebook, again, this would be the title of it. Angles of regular polygons, and then we're going to do some guided notes together and practice it, and then we will wrap this lesson up. So here we go. We are going to take some notes on angles in regular polygons, and this is something that I will expect we will all have down together. And so the term that we're going to be dealing with a lot today, it might seem like something you just gloss over, but we're talking about regular polygons today. Remember, a polygon is a two-dimensional figure that's composed of just straight edges that don't cross each other, and it's a closed figure. We talked about that last week. And what we're going to do today is we're going to detail what a regular polygon is, just as a brief reminder. This is a polygon where we have all equal angles and all equal sides. And so the term regular actually gives us a whole lot of information. All equal angles, all equal sides. So for example, I could draw a regular hexagon. And you do your best to try and do that. And I'll do my best attempt at drawing a regular hexagon where I'm going to get all of my sides being the same length. That's a horrible start. And probably will try and pause this really quick, and I'll try and do a little bit better job. So here's my attempt at a regular hexagon. Looking at this, first of all of the inside angles, or as we're going to refer to them right now, interior angles. So there's 6 of them, and notice how when I mark them, I'm using one arc for each of them because they are all equal in measure to one another. We're going to call these interior angles. And so this regular hexagon has 6 interior angles. And not only that, but it also has 6 exterior angles. And I want to demonstrate how I'm going to draw in these exterior angles for you. If you are to take one of the side lengths and you just continue tracing it beyond where it stops and connects with another side length and kind of make a dotted line, like if you were to extend the side length, and here's what I mean. If you were to extend something that looks like this, and then continue the same thing with this next side length, something like that, what we're going to figure out is that there's another angle on the outside on each of these, and that creates a straight line with the angle that's on the interior. So you'll notice this red angle and this gold angle, or yellow one, they form a straight line. And this yellow angle is what we refer to as an exterior angle. I'm not going to draw in all 6, but you'll notice that here's an exterior angle, here's another example of an exterior angle. And in each case, all of those exterior angles are going to make a straight line with its corresponding interior angle right next to it. So there's a few facts that we need to understand, that we need to get down about interior angles and exterior angles in polygons. So this is worth writing: facts about interior and exterior angles in polygons. All right, so fact number 1. This is a big idea. The number of sides in your polygon is equal to the number of interior or exterior angles. I'll write that down. So this is what that means. If we have a 6-sided shape like our regular hexagon, that tells us that we have 6 interior angles and 6 exterior angles. That was fact number 1. Fact number 2 is the fact that the sum, which again means to add up, the sum of the exterior angles in any polygon is 360 degrees. So let me reiterate, the sum of the exterior angles in any polygon is 360 degrees. In the warm-up problem, we found the sum of the interior angles of one particular polygon. But for any polygon, the sum of the outside angles will always make 360. Fact number 3, and we kind of alluded to this earlier, but if we were to take the measure of the exterior angle and we were to add that to the interior angle, that's going to form a straight line, which means that it's going to make 180 degrees. So interior angle plus exterior angle is going to make 180 degrees. Then, the last little bit of information, and this is merely for regular polygons only. So all of the stuff up above was for any kind of polygon, but now this is specific for regular polygons. The measure of one, and I'm going to underline one here, the measure of one interior angle is equal to the following: n minus 2 times 180. Remember, that was adding all of them up. And then if we were to take that and divide that by n, which is the number of sides, that will tell us the measure of one angle. And hopefully that makes sense. Since they're all the same measurement, n minus 2 times 180 adds them all up. And then if you divide them by the number of angles, you'll get the measure of one specific interior angle. And then the measure of one exterior angle is a little bit easier formula to deal with. Remember, the sum of the exterior angles adds up to make 360 degrees. So if you were to take that and divide that by n, that is going to, again, represent the measure of one exterior angle. And so n, remember, just equals the number of sides in your polygon, in case you were wondering. But this stuff right here, these 4 facts that I wrote down, hugely important, and we're just going to see how they are applied here momentarily, and then we will wrap up the lesson for the day. So this last little bit here on problem 827 kind of is the application of what we just took some notes on. It says, use your understanding of polygons to answer the questions below if possible. If no solution, explain why not. I want to look at the first one, letter A. It says the following: Gerardo drew a regular polygon that had an exterior angle, or exterior angles measuring 40 degrees. How many sides did it have? And what's the name of this polygon? Well, we do know the following. We know that one angle is equal to 40 degrees, and that's an exterior angle. So what we're going to do is we're going to go to our formula that we have that talks about exterior angles. We know that the sum of the exterior angles is 360 degrees, but that doesn't really help us a whole lot. What I just got done writing down, is this formula, 360 divided by n. That represents the measure of one exterior angle in a regular polygon. And so we're told that this is a regular polygon. So this formula tells us, again, one exterior angle. And fortunately for us in this particular instance, we know that this one exterior angle is equal to 40 degrees. And so I can set that equation equal to 40. And this is something now that we've done a million times. We can put this over 1, and then we can get fractions on both sides, and we can cross multiply to try and isolate our variable n. So 360 times 1 is going to yield 360. And then on this side, I have 40 degrees times n. And so I can isolate n all by itself, solving for the number of sides. And 360 divided by n is, 360 divided by 40 is going to be equal to 9. So that tells me that this is a 9-sided shape. So we'll say this shape has 9 sides, and we call that a nonagon. That was the name that we took down for that the other day. It's a nonagon. So that was letter A, working backwards, starting with a formula that we have, allowing us to be able to determine the measure of one, or determine what the shape was given one exterior angle. We'll try one more, and then we'll wrap up the lesson. We're going to look at letter B. Letter B, it says a polygon has an interior angle sum of 2,520. So they tell us an interior sum is 2,520. How many sides does it have? So again, what we're going to do is we are going to start with the 2,520 degrees. That was the sum of the interior. That's what we started with. And what we're going to do is we're just going to look for the equation for the sum of the interior angles of a polygon. And we actually have that equation. That equation is equal to n minus 2 times 180. So I can replace that with the actual equation for the sum of the interior angles. And I'll set that equal to the given measurement in our problem. And so now my goal is to try and get n all alone. And there's a couple ways you could do this. But what I'm going to do is I'm going to divide by 180 degrees on both sides. I'm going to try and work my way to get n all alone. Those go away. 2,520 divided by 180. I'm a genius. And so then I know off the top of my head that's 14. Then what I'm left with on the right side is just n minus 2. So lastly, we can add 2 to both sides to get n all alone. So that leaves me with 16, and 16 then is equal to n. That is the value of the number of sides. So we don't have a specific name for that shape. We would just say that this shape, or the shape, is a 16-gon. That would be the name that we would give it. It's a 16-sided shape. And so, as you can see, what we just did was a couple application problems of the notes that we took up above or earlier, using the information about those facts that I gave you. You can go back, rewind, make sure you get all of this. And this was lesson 8.1.3. Make sure you go on and you can take a look at the concept check, and then we'll touch base. Let me know if you guys have any questions. Peace out.